Hey everybody, it's Taki117 here, back with Taki's Space Program. So, I am really glad I put that lunar communication satellite in orbit of the moon. Because, if we take a look at our map view here, we can see that I'm bouncing my communication signal off of that relay back to Earth. Which means I do have full control, but I'm kind of curious. Oh, so this antenna is not suited for the ranges I'm covering. I'm only covering about 36 kilometers of the surface. So, unfortunately, I need to change dishes on my other satellite. Good news is, I can still perform the maneuvers I need to get this satellite going in the right direction. So I'm actually going to add a maneuver here about 19 minutes out. And I want my periapsis to be 500 kilometers. Oop, that's a little much. There we go. So I'm now going to execute that node. And this is going to put me on a 500 kilometer polar orbit. Actually, before I execute this maneuver, I'm going to ditch my translunar stage. Now, the puff of smoke is the decoupler between my fairing base and my engine exploding. Not entirely sure why it does that, but it's irrelevant. I do still have plenty of power generation on board, so I don't need to worry about that. And as long as my satellite doesn't go to the dark side of the moon, I should be covered. Now, of course, if I can't perform this maneuver, it looks like I'm gonna be good. Or if I can't perform the circularization maneuver, then I'm just going to end up in a very elliptical orbit of the Earth, similar to my Luna 3 mission. There we go. We're now going to circularize at the next periapsis. Go ahead and execute that node. And we're good. Again, as long as that satellite maintains communication, I have a network, or I have connection back to Earth. So I'm actually really glad I put that satellite there in a zero inclination. So just waiting for a burn here. There we go. Executing our burn, you can watch the orbit around Earth change. until we're now fully captured in the moon's sphere of influence. We still have that communication connection, which is good. And there we go, maneuver complete. That is beautiful, that is. So I'm going to point normal positive. It's 0 roll because that will point my instrument at the moon. I'm going to go ahead and start that scan. Oop, I'm too high. Okay. Let's point retrograde. Drop down to 250 kilometers. And this is another reason I use a lot of fuel on my spacecraft, so that I can do maneuvers like this. I don't have to worry about, oh, I don't have the fuel to do that, I guess I'm stuck here. I can just lower my orbit and I'm good. Now again, I'm not planning any of this more than, this is what I need, this is where I need to go. I know about how much fuel I need to get there, but beyond that, I don't really have a clue. So a lot of my rockets are going to be very over-engineered. Hopefully I don't lose my connection. Okay, we are good. I am beginning to scan the surface, as indicated by the green beam there, and if we open up our map, we can already see that we've mapped some of the moon. We've mapped 6.9% of it, actually. There we go. I always like watching maneuvers happen. And just something about them that makes me all warm and fuzzy. There we go. So we are now mapping the moon. And let's point prograde. There we go. A little bit better solar coverage there. There we go. So, I'm going to head back to the Space Center and launch another mission. So, I don't know what I'm going to launch, though. So, I've already done 7% of my biome scan. Need science data from space around the moon, but I'll get that eventually. So it looks like you guys are going to... Oh. As an old thing, because I'm not actually changing spheres of influence. So, but now it's a matter of rinse and repeat. What I am going to do, however, is I'm going to edit this spacecraft to put a different dish on it. The main reason I'm putting a different dish on it is because I don't need the super long range one. I just need within the system. So it is going to take, a couple of hours to make that switch. So it's the same rocket, it's the exact same satellite. Again, just swapping that out for this works. Something a little more in system. There we go. Put these back on. Actually, I'm going to put those with that engine because if my last launch was any indication, I can shut it down and it's going to take half an hour to make that switch, but that's fine. But I can activate the engine and deploy the fairings all at the same time. So, yep, I'm going to go ahead and make those edits. There we go. We're now going to roll it out. And then we're going to launch once again into the plane of the moon. Now, I really like doing these realistic looking launches. The first satellites were actually really small. Explorer 1 was about 6 feet long, give or take. It wasn't very big at all. The first communication satellite was a little bit bigger than a softball. I mean, NASA in the early years was working with some really antiquated, maybe not necessarily technology, but they were working with old military hardware. So there were a lot of, early rockets like the Redstone missile, the Titan missile, the Juno missile. All these missiles, they were removing the explosive payload and just plopping the satellite on there and calling it good and launching it. And that's what they did. I mean, there wasn't a whole lot to it. So that really limited the size of the satellites. They couldn't weigh much more than the original payload. But, as rocket technology got better and as just technology in general got better, it became a lot more, I want to say, feasible, practical to kind of build specialized rockets. here we go. See, I'm already well over 100 kilometers and I still have 200, 300 meters a second of delta V left. So this is a very efficient rocket. And again, dropping that lower stage. I don't need it anymore. Cut the engine. Let's set up a circularization burn. $70 kilometers. Ditch the fairing. Extend my solar panels. Set my target to Earth. And because I do know I have a lot of power generation, I'm going to go ahead and activate at least my two omnidirectional antennas. I actually want to roll to 90 degrees to maximize my solar panel, to maximize my solar collection for my solar panels. Actually, I'm going to execute that node. See the moon over there. Now we've run into a slight problem. I'm off by 60 degrees. Because, well, I forgot to match inclinations. Whoops. So this is going to be interesting. I am going to go with it. See, that is almost the node. There we go. Let's see what I can make happen here. This particular maneuver is probably going to be excessive as far as delta V is concerned, which is why, again, I over-engineer all my rockets so that if something like this happens, oh dear. Okay, so we're at least in orbit. I can try to transfer. Ew. Alright, so we are going to match planes. It's going to take us well over 2,000 meters a second of delta V. Let's see if we can't combine things. So I think what I'm going to do is I'm going to bring this out. I'm going to spend $800 meters a second to bring this out. Let's make it 900. So that it almost 800's good enough. 850. Let's do 850. There we go. So execute that node. That maneuver is only going to take us 90 meters a second, which is good. Alright, I am also going to activate my dish. Now, you're probably wondering why, I'm bringing my apoapsis up prior to performing a plane change. There we go, and it's activated. And the reason has to do with the Oberth effect. As you saw, my plane change maneuver going from a 56 degree, almost a 57 degree plane change maneuver was well over 2,000 meters a second of delta V, which I just don't have. So by spending 900 or so about half the delta V, by first pushing my apoapsis out and then performing the plane change, I'm saving 1,000 meters a second of delta V, which I can then use to circularize my orbit, transfer to the moon, and continue the mission as planned. Like I said, I forgot to align my planes before launch. I wanted to give you guys a daytime launch instead of, a nighttime one. So I'm having to do a correction maneuver. There. See, now it's 90 meters a second. It's going to take me a while to get there, a little over a day, 18 hours. But because I did switch the dish, I do have connection this entire time. These messages down here are my lunar satellite passing into the dark side of the moon, which is blocking the sun, which is preventing me from charging my batteries. And I'm using electric charge, but I'm not generating any of it. So I think when I get over there, I am going to turn on my fuel cell just to see what it gives me as far as power generation on the dark side. This burn is also only going to take 3 seconds instead of several hours to perform. So here we go. Watch that orbit change. Isn't that just beautiful? So now we've matched planes with the moon. Almost exactly. Yeah, there it goes, exactly. Now we're going to see if we can home and transfer to it. That works well, actually. It's a little high, but that's okay. It is going to intercept my target. It's just going to take a long time to get there. Well, that's okay. Again, getting more warnings about my altimetry probe. Let's see how this is doing. Oh yeah, we've got plenty of electric charge. I mean, it's not great. I could probably stand to roll the spacecraft a little bit and get some more sun on this other panel that's being blocked. But for the moment, we're doing pretty good. There's a blue marble we call Earth, which is weird because the Earth is covered in 70% water. But yeah, that's what ancient peoples came up with. There we go. We are intercepting the moon. I think I'm going to roll to 0 degrees just to get both of my solar panels charging. And here we go. So I am going to swap over to my that's weird. It is saying my lunar altimetry is losing power, but I don't know why. Bet this dish uses more power than the other one. Oh, I know why. It's because I'm time warping. So, during time warp, all of your electric power generation goes up. Your generation, what you're using, everything really. So you're gonna have to find that nice equilibrium between how much you're generating, how much is being used. So, anyway, we are slowly falling towards the moon. So, we will catch up with that next episode. And until the next time, I'm Taki117, and remember, it's only rocket science.